We already seen how to get the state space model for a given system. Now there is always a need to convert the state space model into transfer function model, because all the techniques that are available, conventional techniques like root-locus, bode, Nyquist, needs the transfer function model. Now we will see how to convert the state space model into a transfer function model. So let us take the state equation. Your state equation is x dot is equal to ax plus bu. So x dot is a dx by dt, so first differentiation is equal to a into x of x plus b into u. So x is a state variable, a and b are in state matrix and input matrix respectively, u is the input. Now, so for this let us apply Laplace transform to we know that the Laplace transform of d by dt is nothing but s. So we already have dx by dt, therefore the Laplace transform of it, x of s minus x of 0 is equal to ax of s plus b u of s, where u is the input. Now in transfer function we assume initial condition 0, therefore sx of s is equal to ax of s plus b u of s. Now let us take this ax of s to the other side and take x of s common. So when you take x of s common, s minus a, where s is a variable, Laplace variable, and a is a matrix. Therefore I cannot do this subtraction, therefore s into I, where I is the identity matrix having the order of a. So x of s, si minus a is equal to the other side we have b u of s. So what is this x of s? If I take this other side, then x of s is going to be si minus a whole inverse b u of s. Now this is x of s. Now we have the output equation. What is output equation? Y is equal to c x plus du, where c is output matrix, d is the transformation matrix. So when you apply Laplace transform to this is y of s is equal to c x of s plus d u of s. Now substitute x of s here. We already have the x of s, therefore y of s is going to be c into si minus a whole inverse b u of s plus d u of s. Again here I can take u of s common, therefore your y of s is equal to c si minus a whole inverse b plus d. Now I can get the transfer function directly. Y of s by u of s, output by input in Laplace domain, is c into si minus a whole inverse b plus d. So this is the formula used to get the transfer function from any state space model. Now to understand this, let us illustrate with an example. Look at this example, and the problem statement goes like this. Obtain this transfer function model from the given state space model. So x dot is equal to a matrix 0 1 minus 2 minus 3 x plus 1 0 b matrix u, and output matrix y is equal to 1 2 x. So this is a state model. We need to convert into transfer function model. So first of all, extract what are the ABCD matrices from this. So A matrix is very clear, it is 0 1 minus 2 minus 3, it is 2 by 2 matrix. B is 1 0 and C is going to be 1 2 and D is 0. So once the matrices are available, it is only the substitution in the formula. Transfer function formula, we know that y of s by u of s is equal to c si minus a whole inverse b plus d. D anyway 0, so first we will find out si minus a whole inverse, then we multiply c and also b. Now let us see how to calculate si minus a. We know that s is a Laplace variable and I is nothing but identity matrix, where identity matrix 1 0 0 1. Then we substitute here s 1 0 0 1 minus my a matrix 0 1 minus 2 minus 3. Then you do this simplification, you will be getting it as si minus a is equal to, we have s minus 1 and 2 and s plus 3. So this is a matrix Si minus A matrix. We want to get the inverse of it. Since it is a 2 by 2 matrix, the inverse becomes very easy. So Si minus A whole inverse is equal to 1 by AD minus BC. So A is S into S plus 3 minus B, we have 2 into 1. So again inside the bracket we have D minus B minus CA. So D is S plus 3, 1 minus 2 S. So this is my Si minus A inverse. Now when you still simplify it, you are going to get as a 4 elements. The first element is S plus 3 by S square plus 3S plus 2, and the next element is you have 1 by S square plus 3s plus 2, and here the third element is minus 2 by s square plus 3s plus 2, and the final is s into s by s square plus 3s plus 2. So there are 4 elements in SA minus A whole inverse. So let us take each element. So first element is phi 1 1, phi 1 2, phi 2 1 and phi 2 2. So once this is there, then I can write SA minus A whole inverse as phi 1 1, phi 1 2, phi 2 1, phi 2 2. So we need to do the other multiplication. First we will multiply with the B matrix 1 0. So when you multiply 1 0, then you will be getting only a first column, that is a phi 1 1 and phi 2 1. And again I need to multiply the C matrix. What is the C matrix? 1 2. So when you do that, you will be getting phi 1 2 plus 2, phi 2 2. So this is what the transfer function final. Anyway, D matrix is 0. So take those two elements and you just add it. When you add, you will be getting the transfer function as y of s by u of s is s minus 1 divided by s square plus 3s plus 2. So this way we can find out the transfer function from any given state space model.